Dear participants, we are on the sixth day of this international workshop on digital image processing. Today we have a speaker, I can say a versatile personality, Dr. Emmanuel David sir, and he is going to deliver his talk on vector data formats, and it is related with introduction to digital image. And I'm sure today you will receive all types of inputs from Dr. David sir. Before proceeding ahead, I would like to request Dr. Lalita Tambe ma'am, who is working as a colleague in my department, and she is also a versatile personality. I request her kindly introduce today's speaker. Over to Lalita ma'am, please.
Yeah. Good evening to one and all present here. I have been given this opportunity of introducing Dr. T. Emmanuel David. Before starting the session, I would like to give his introductions. Dr. Emmanuel David, sir, working as an assistant professor in Department of Geology, Malankara Catholic College, Kanyakumari, and handling subjects are Applied Geology, Annamalai University, Chidambaram, Tamil Nadu. His total teaching experience is around 11 to 12 years. His specialization in remote sensing and GIS, satellite image processing, geographics, geomorphology, and geo-environmental studies. He has published a total of 10 journals and 2 conferences, presented a paper on land use, land cover, change detections along to Titoran Coast in the ICSSR International Conference. And another, he participated an international conference in, the title is Earth Dynamic Perceptions and Deadlocks. And also participates in 8 workshops. He also took 3 guest lectures. Sir, I welcome you behalf of Devruk Shikshan Prasarak Mandal ASP College and all the collaborating institutes. And sir will cover in today's lecture at vector data formats, binary and decimal numerical system data types. Since sir is working in this field, there is no doubt that today's session will benefit the students a lot. Thank you, sir. You can start your lectures. Participants are waiting to hear you. Thank you so much.
Thank you, Tambe madam. Dear participants, you might have got an idea about the versatile personality of today's speaker. His overall contribution is in the area of digital image processing. I request Dr. David sir kindly proceed ahead. Over to David sir. Please sir.
Good evening to everyone. Thank you so much, Lalita ma'am, for giving a great introduction about me. I'm really, first of all,
Most
I want
welcome,
to
sir.
say sorry to everyone, and importantly, Sardar and Patil sir, because my presentation has to be done in start of workshop. Due to some unavoidable situation, I present it today. There is a lot of inconvenience. I'm really very sorry. And secondly, we are today going to discuss about the topic of vector data formats, and it is a digital image introduction about the digital image. It's main scope of this presentation is following. First, overview of the data, then basic concept of the vector data, then data acquisition, data formats, importance of the vector data. This entire presentation will help to understand the basic level of concepts about the vector data. And I'm going to share some of my experience in handling vector data. Well, I'm present there is network issue connecting some any issue. I will continue my presentation from my mobile. Please, anybody, please intimate me. Okay. Is it audible to everyone?
Sir, your voice is breaking in between, and if it is possible to shift to mobile, and if you can increase the clarity of voice, it will be more appreciable.
Yeah, sure.
Please.
Is it okay now?
Now our voice is clear.
Sir, is it okay now?
Yeah.
Okay, okay. So, in the part of the overview of the data, we have to know data is the main key component of GIS. So you know all about the GIS, Geographical Information System, and or geospatial data. That is the main key component. Without without of the data, we are able to mapping, analyzing, and modeling. In the overview, the data is characterized spatial and not spatial data. So spatial is the relevance of that is a representation of real earth features, spatial features. Okay. These are the spatial features mainly raster. In the vector data, that is a discrete form of spatial features represent as point, line, polyline, and polygon. In the form of the raster data, the spatial features represent in grid data and image data. In the overall, the combination of the vector and raster data, tin is represented, and the tin is nothing but that is a triangulated irregular network data. This is the tin data is representing in the unit of triangular in shape, same as the grid and the same as the image. In the raster data, the unit raster data is represented as square or cell or pixel. In tin data, that is representing triangular form, and the triangular form of the each units containing point file, line file, and polygon files. Okay, in the major portion of the spatial data, it's fully controlled by and characterized by non-spatial data. The non-spatial data is otherwise called as attribute and tabular data of the spatial features. So now we are getting to the topic of the vector data. Vector data is representing the spatial features of the exercise and with the assigning of attribute of those features. It's composed of discrete geometrical location of x and y coordinate value connecting vertex. The vertex define the shape of the spatial objects in vector data form of point, line, polygon. The vector point is a zero dimension and only the property of locations. It's made up of point or set of points. Each point is defined by single latitude and longitude coordinates. That means XY coordinates. In the data structure of the point file, you can see in the image. In the point file, if you are creating a point file in any GIS software, that is stored in the geo database in the form of longitude value of x and y. This is the basic concept of the storing of within the process of software. Next, this is the one-dimensional characterization and a property of length and direction. Okay, other one here, line, polyline. Okay, the line have one dimension and has the property of length and direction. It has two endpoints and they may have additional point to define the shape of the spatial features. So the two endpoint is beginning from one point to one point is a starting point, another point is a ending point. In between of the points, defining the shape of the features. Okay, so the line is represented by a series of x and y coordinates. The x and y coordinate is geographical coordinate, latitude and longitude. The data structure, when you start to digitizing the line data, it's line data beginning from first vertex is stored in the form of x1, y1, and second vertex in the storing in the form of x2 and y2. It's continuous in n number of x and n number of y ended with the x and y. Okay, so this is the example of image representing the line vector data. Okay, then after vector data in polygon, that is representing two dimensions and is the own property of area and perimeter. It consists of three or more vectors that are connected and close to define the area of polygon. It is share their boundaries with other polygons. There is a lot of special characters in the polygon, but the limited of time I just mentioned some of points only. In here, the data structure of the polygons ended and starting point and ending point is at the same point. You can see that the data structure x1 and y1 started to digitizing and its each and vertex is continuous as x2, y2 and x3, y3 and continuous and ended in the same point of the x and yn. Then at the important characterization of the carrying of the data, line, point, line, everything is carrying with describing characterization of attribute data. It is organized by rows and columns. The rows is also called as records. The records of each and every single spatial feature, single spatial features like if suppose trees you are going to digitize in the point file, the every records are registered as object ID in record of row form. And in the column is also called as field or variables. Each and every field or variables describing the spatial features of their quality and quantity. The attribute data can be stored as four different field types in table or database as character or numerical data of integer or floating and data. Attribute data help you perform spatial queries and analysis. In here, further, this main characterization of the field types divided as double, float, logical, long, short and variables. You can see in the every JS software begin creation of the attribute data, it will show double, float, logical, long, short and variables. In the double fields store 8 bytes double precision floating point values. Then the float field store 4 byte single precision of floating point values. In logical fields, that is only representing a true or false of data representation. Then after the long integers of field store 4 bytes of integers values plus or minus more than trillions of values. In short field integers only representing 2 bytes of integer values plus or minus 32,767. Variable characterization is represented in the form of string data. These are the basic concept of vector data to describing the entire spatial features of the Earth surface. So Next topic is data acquisition. In the data acquisition, in the past, it is very difficult to serve, find and access the data. You can see that image. They are absorbing the data from the map or field visit, or it's very difficult to observe and monitoring in traditional method, and also very difficult to storing the data, because if nowadays we are storing the every each and vector data or any data simple of memories in small devices. At the past time, that is very difficult to store the data, but nowadays we can getting data from different resources with derivative products. Derivative products means processed data we can getting from the resources. Okay. For example, we can compare the traditional method and new method. Also, is it audible, sir? Okay. In here, the data acquisition, we can compare the traditional method and new method. In traditional method, we can download the elevation data, for example, SRTM data, cassette data from the different website. We can collect and pre-process data using a software to create the hill shape, slope, aspects, and derivative maps. It has it have a long process to extract the information, because if you are collecting a wide area of the pen, we have to collect multiple set of tiles data from the uh, multiple set of satellite data. This multiple set of satellite data we have to pre-processing and mesh together to form the elevation data, and we have to extract in the elevation data. In the new method, every software packages and online services have streaming of elevation data services, because they are already collecting the elevation data and make that elevation data to store and create a derivative product from the elevation data. So at the case, for example, you can use that ArcGIS, and you can use the global mapper. We can get the derivative maps from the software packages. So that data is no need to pre-processing, and we can directly use the derivative products. That level of advanced is nowadays developed when compared to the past data acquisition. So in data can be generated widening variety of way with the geographical coordinates. If you are started to research, if you are started searching a data, if you find first the existing product of the data, and afterward, if you can't able to get the data, afterward you have to collect the uh, new data from existing resources. In here, field survey, we can collect the data through GPS and total session survey. Some mobile apps, we can collect some field survey information. And afterward observation, we can collect some information through the field work. And afterward, data are gathered from ground-based photographs, maps, satellite imageries, grid data, etc. In the last portion, you can see that IoT feeds. IoT feed is nothing but that is a Internet of Things that is that can able to collect a real-time data from anything. For example, rainfall data or sea level data or water level data. These kind of precipitation level data. These kind of data are collecting using of IoT device of real-time observation, this larger number of data we can use during the IoT things. So this is I am going to discuss the vector data acquisition through the global resources. Many government agencies have set up a website for distributing the regional and local level of free data sets. Some of the main website I noted here for your kind reference, because this is one important resources to collect over the globe. We can collecting the vector data. This is a exhaustive list, but it provides some use starting point for your research. Okay, so this is the main thing. If suppose whoever are working in the over the larger area of any countries based work or any state level of work, we can collect that information. If you are working in the local level, district and taluk level, don't use these data, but this is only the larger and regional and the local level of data sets. Okay, so in here the first we seen the Zizin, and that is a website is that is a Columbia Education is type of website producing course resolution data of economic activity, environmental health, natural hazards, population and poverty. In the portion, database of global administrative areas, GADM, that is producing a database of administrative boundaries, locations, and name of the countries, and subdivisions such as provinces, then counties means district, state level of boundaries. Okay. Then after GeoFabric OSM, so you can search that website. GeoFabric, that is a wonderful website. We can collect detailed information about the entire global fields. For example, places, road, rail, and network way. Then after this is available in the form of shapefile, and also we can get from the KML and XML file format. Okay, the last one is gridded population of the world version 3. They have multiple versions, so versions 1 and 2 and 3. I think the last version is 4. These GBWB versions provide the population density, settlement data, urban extent, and subnational administrative boundaries for much of the world. They covering a larger area to providing the population statistics, population data. In here, a harmonized world soil database provides global soil map database. That is a vector data format. We can't able to collect any we can't able to collect these kind of informations. Actually, we can't able to create these kind of informations. That is a global level of soil maps database we can get from the harmonized world soil database. Then after King's College London Geodata portal, they are providing entire KML file format of hydrology, hydrology, then deforestation and biodiversity data. And you can see that OSM is a best source of vector data, because OpenStreetMap is a vector source. That is OpenStreetMap is that is providing the worldwide vector data of the street building footprints and infrastructure. This data we can see in the Google Earth. Google Earth data. If you want to if you want to collect any Google Earth information like point, line, polygon files, you can directly use the OpenStreetMap to collect these informations. Okay. The last one is NASA Tropical Rainfall Measuring Mission. That is a TRMM. The tropical rainfall measuring mission is providing 0.25 degrees of precipitation in HSTF format. Yes, HSTF format is there, but we can convert as the HSTF format as raster data or vector data. You can use it. This is the hourly and monthly base of data. Okay, so now I am going to demonstrate the vector data acquisition in gravity and topography. I'm not going to here. This is the data website, that is a topex ucsd.edu website. You can use this link to see that extract the x, y, z grid values of topography and gravity. Topography means they are providing mm, elevation and also bathymetric data. If the many peoples working in the coastal region and most of the people working in the coastal region, the people this is the topography information very useful, because we can't able to collect the bathymetric data. That is very difficult to handle it, and we can't able to get the data. This is very easy process to get the data. We can directly input your northing and westing and easting southing values to get the topography of the informations. That is providing, if you are input the latitude longitude of the topography, it will get, it will automatically generated the x, y, then after z. That's when the x is the latitude value, y is the longitude value, z is the elevation value of data automatically created, and afterward you just copy that information, convert to the excel file, and directly input the any js software as a xy uh, included as a point file in any software. Okay. In portion of the gravity, many people is working on the gravity field to observing the Earth gravitational field. In that case, the gravity, you know about that, the constant value of the gravity is 9.8 meter per second. Uh, that is a constant value, but the gravity value is changed according to the equatorial region to polar region, and low elevation, and based upon the topography, based upon the high density of rock formation below the surface, the gravity value is fully changed over the world. Same as the topography. Topography also changed over the area, over the sea or land. That is a lot of topography value is changed plus or minus. Same as the gravity value also change plus or minus. You can download the gravity values if you are using if you are working in the gravity related of explorations. That is a vector data format. There is a lot of popular file format is there. I just going to present some of things: shape files, XML and KML file, object for coverage, object view, interchange, spatial database engine, digital line graph, GeoJSON, AutoCAD. Then after these are the main vector file format. Most of the softwares, most of the GA software working in the basis of the shapefiles and XML and KML file. Okay. The final is importance of the vector data. Vector data tend to be better representation of reality due to accuracy and precision of point, lines, and polygons. It is always combined with set of locations with attribute information and temporal contents. Vector data tend to be more compact in data structure, easy to store and transfer. Without difficulty, we can define projection and coordinate transformation in the vector data. It is deliver a visible representation that is sharp, clean, scalable, and easy to understand by any.
Thank you, sir, for your resourceful deliberations in the area of vector data format. Now I request all the participants to kindly ask the questions if you have. and I'm sure Dr. David is one of the knowledge, knowledgeable person in the area of or nutrition pharmacology, and definitely he will assist you and definitely try to give answers to your question. Please, participants may ask the question through chat box also. Sir, one participant is asking that is it possible to share the PPT? If you,
Yeah, sure, sir. I will
yeah,
share my PPT.
yeah, yes, please share me what's on WhatsApp. I will share in the group of the participants. Sir, Amal Raj has typed his question in chat box.
Is there anybody here? Actually, I have some. I'm in home, and that's why there is some difficulties. Anybody have questions in vector data? I can practically I can. If you are office user, there is a option is the feature to XML. You can search that feature to XML. You can directly input the XML to convert to the shape files. And the other option, if you want to observe any Google information, please use the OSM website. Open source information. OSM is a very good resources that is more or less equal to the Google Earth information in the vector data. Amaraj, can you able to understand and